हरि करना।
So now let's also look into the standard error. What is a standard error? Standard error is a single metric that sums up the variability in the sampling distribution. Okay, sampling distribution. Again, always make a distinction between data distribution, sampling distribution. These are completely two different entities. So, standard error is a single metric that sums up the variability in the sampling distribution for a statistic. The standard error can be estimated using a statistic based on the standard deviation S of the sample values and the sample size. So, whatever you see on the screen, this is called standard error. Standard error is nothing but the standard deviation of the respective sample divided by square root of the sample size. That's it. That's what is called the standard error. Okay, you can see that. Is it clear, or should I repeat one more time? Standard error can be estimated using a statistic based on the standard deviation S of the sample values and the sample size of the n. Got the point? So as the sample size increases, the standard error decreases. That's the reason from this distribution, we are approximating the normal distribution. As the sample size increases, the standard error decreases corresponding to what was observed in this picture, and also in this picture or in this simulation. So the relationship between standard error and sample size is sometimes referred to as the square root of n rule. Let me put it in writing. The relation between the standard error, that's called SE, and sample size is sometimes referred to as the square root of n rule. Okay, to reduce the standard error by a factor of 2, the sample size must be increased by a factor of 4. So to reduce the standard error SE by a factor of 2, the sample size must be increased by a factor of 4. Okay, so the validity of the standard error formula arises the validity of the standard error formula arises from the central limit theorem. In fact, you don't need to rely on the central limit theorem to understand the standard error. Consider the following approach to measuring the standard error. So, measuring SE. So, collect a number of brand new samples from the population. First step. Step 1. Collect a brand new samples from the population. That's 5. Then step 2, For each new sample, calculate the statistic. Obviously here it's a mean. Then calculate the standard deviation of the statistics. Step 3, calculate the standard deviation of the statistics computed in step 2. Then finally use this as your estimate of standard error. So step 4, put all in the respective in the formula, and then measure SE, standard error. So this what is called standard error. In practice, this approach of collecting new samples to estimate the standard error is typically not feasible. So fortunately, it turns out that it's not necessary to draw brand new samples. Instead, you can use bootstrap resamples. In modern statistics, the bootstrap has become the standard way to estimate the standard error. I will tell you what is that, but not to worry at this moment. So it can be used for virtually any statistic and does not rely on the central limit theorem on the other distributional assumptions. Okay, before we wrap up this standard error, I just want to make sure one thing: standard deviation is not standard error. Again, I just want to repeat, standard deviation is not standard error. Do not ever confuse a standard deviation, which measures the variability of individual data points, with standard error. Standard deviation measures the variability of individual data points and standard error measures the variability of sample metric. Measures the variability of sample metric. I hope you got the point. That's why I put both at same page. Similarly, never ever confuse with statistic and parameter. Okay, and statistic is not parameter, and data distribution is not sampling distribution. Okay, remember this point. This is a very important. Never ever get confused with these things.